Hello, my name is Charlie Marsh, and this is my video presentation and demo of my honours project for my final year at the Robert Gordon University, with the subject focusing on the comparison of stereoscopic technology in 3D animation. When stereoscopic 3D, or S3D, was featured in James Cameron's 2009 sci-fi film Avatar, the technology was perceived then to be a new way of experiencing films in theatres. However, since then, the popularity of the technology has dropped considerably, and the conventional form of watching films in 2D, though at varying resolutions and frame rates, has dominated in its place. The goal of this project is to find out if stereoscopic 3D can still provide more immersion than a 2D image. My aims and objectives for the project are to research and discuss features of stereoscopic animation and how the technology has been used over the years to create a sense of photorealism and immersion, as well as any other camera techniques that achieve similar results, to create a 3D animation featuring the researched information put into practice using a selected 3D software package, and to evaluate the camera techniques by showing two examples of the animation with different render settings to a group of people and inquiring about their experiences of watching these animations. The finished animations will be played later on in the demonstration, though the timestamps are provided here. Please be advised that the stereoscopic production will require anaglyph glasses to watch. Stereoscopic technology is when two images are taken of an object at marginally differing angles, which are then joined together to create a 3D image, the idea being that the layout is very similar to that of the human eyes. Because we can see objects at slightly differing angles, we are able to detect depth in surroundings rather than seeing a flat image. While this is not a necessity for viewing all forms of stereoscopy, some forms do require the use of special glasses, of which there are varying types. For example, anaglyph, or red and blue glasses, cancel out the solid filters placed over the left and right images respectively. Other types of glasses are designed for 3D images that filter light through either vertical or horizontal polarizers. For creating the animation, as well as the models and assets, there were several animation packages to choose from. Autodesk's 3ds Max is aimed at a wide range of users, from novices to professionals, all with the intent of creating and designing characters, creatures, buildings, and other models, which can then be used to produce high-quality renders. Autodesk's Maya is aimed more towards the professional, being used by many mainstream film industries such as Framestore and Blue Sky. Maya also has a complex stereoscopic camera system for animating and rendering productions in S3D. Blender is an open source animation package designed to incorporate many aspects of the production process. Since being updated to version 2.8 in October of 2019, Blender has become a worthy contender for many of the industrial-grade animation packages. Maxon's Cinema 4D leans back towards Maya's level of complexity, though similar to Blender, Cinema 4D houses the ability to work on multiple stages of the production process within one project. Whilst all of these packages offer free discounts to students, Blender is free regardless, due to being open source. Originally, the plan for the project was to work with Maya's stereoscopic camera setup, with models being produced either also in Maya or in 3ds Max. However, due to familiarity, availability, and the option to have multiple different processes available within the project, Blender 2.82 ended up being chosen for the project's production. One of the main challenges in terms of assets was the creation of the dinosaur, in particular, the modelling and sculpting methods. Creating the creature was a fairly long process, though thanks to the various facilities available within Blender, everything was easy to organise. The model was formed from a cube mesh, which was taken into edit mode and modified with edge loops and extrusions. Scaling each group of vertices had to be done carefully in order to keep the mesh as naturally symmetrical as possible. Proportional editing proved useful in forming the basic overall shape of the mesh. Once this was constructed, the number of polygons was multiplied for better detail and taken into the sculpting tool to add some base skin details, such as muscle bumps and scars. The sculpt benefited from having a larger polygon count, though this result did require some reduction. Another crucial part of the creature was the bone structure, which would be used for animation. Using Blender's armature object, a quadruped-style bone structure was created. Extra bones were also created for the teeth, nails, and eyes, which could be linked to the main skeleton. The bones were then linked to the mesh with automatic weights, meaning that they would be assigned automatically to the limbs of the mesh. This required some weight painting, or skinning, to separate the polygons from certain bones. Whilst the textures, references, and the high poly tree model were found externally, all other assets were created by me for the production. Modelling the grass was much more straightforward than the dinosaur. The individual blades consisted of plain meshes with a number of edge loops added and deformed to create natural bending. These objects were cloned to create different types of grass clumps, varying them on height, number of blades, and in which directions they pointed. These individual grass models could then be appended into a scene project, where they would be applied to a terrain model with a particle system. The models also had a colour ramp shader applied to randomise colour when duplicates were made, representing various ages of the grass. A similar method was used with trees when creating the opening shot. Here's a sample clip from the production pipeline. To maximise system efficiency, objects that weren't animated were hidden in the viewport, though can still be seen in the final render. The final animations will be played back now, one in 2D and the other in stereoscopic 3D. For the evaluation of the animations, I comprised a survey consisting of 20 questions, all to do with the stereoscopic technology and other camera techniques such as motion blur or camera shake. Due to current circumstances and availability of 3D glasses, only my fellow flatmates were able to take part. However, the extended list of questions, along with the extra feedback, did prove beneficial. Finally, here's a reflection on the success of the project, based on the aims and objectives.